Look at this animation. The chaotic data condensing into a uniform shape represents the concept of software abstraction. Building AI agents with raw LangChain code gives developers absolute control, but it often results in brittle pipelines that require constant maintenance whenever dependencies update. The industry's proposed solution to this bottleneck is a move toward visual, drag-and-drop orchestration tools, but many senior developers instinctively recoil at that approach. The assumption is that a graphical interface forces you into a restricted sandbox, a prototyping toy that can't handle production-level edge cases. Flowise is an open-source platform at the center of this debate, promising the ability to build those same AI agents visually. To understand its utility, we have to look past the graphical interface and examine what the system is actually compiling underneath. Consider this side-by-side comparison. On the left is standard implementation code. On the right, the visual node representation of that exact same logic. When you look under the surface, the graphical layer dissolves. Flowise operates as a visual compiler for those raw LangChain primitives. It is a distinct orchestration layer built on a React and Node.js architecture. The visual simplicity on the screen is an interface masking a production-ready engine that requires a closer look at its backend. The first hurdle for an enterprise AI stack is deployment. Engineering teams need control over security and environment isolation. Running proprietary data through cloud-hosted, closed ecosystem visual tools creates security risks when you're operating behind a corporate firewall. Flowise uses a unified monorepo separating the graphical interface from execution logic. The canvas is a front-end React application, processing user inputs to generate a specific state. Execution is decoupled. The generated state travels across the boundary to the Node.js environment, executing the AI logic. Because the execution environment uses standard Node, engineering teams can deploy the stack locally using Docker Compose or native Node.js. This self-hosted architecture keeps data processing within your own infrastructure, which addresses the primary enterprise security concerns. It also allows administrators to lock down API key permissions on the backend, shielded from front-end vulnerabilities. This decoupled architecture provides the security and isolation required for a production enterprise stack. Beyond deployment, the hardest problem in AI orchestration is vector state management and data grounding. Retrieval-augmented generation pipelines often struggle with data deduplication or keeping vector stores clean as documents are updated. Flowise addresses this by integrating LangChain's Record Manager utility directly into the workflow. Look at how the data moves. Raw documents enter the central Record Manager component. Record Manager actively cleans and deduplicates the inputs, creating stateful embeddings to track what has changed. Those clean vectors route directly into a PostgreSQL vector database. Native support for PGVector allows for scaling up to enterprise-level data workloads. Many low-code tools rely on lightweight, ephemeral vector stores that struggle as data volume increases. Finding these foundational database controls exposed natively inside a visual tool is a shift from typical prototyping software. By handling stateful vector management, the platform provides the infrastructure required for reliable, high-volume data retrieval. Standard semantic vector retrieval is the current baseline for RAG, but it reaches a limit as data grows in complexity. Corporate data is deeply relational. You need retrieval systems that understand how different concepts connect, rather than just matching text similarity. Handling that relational complexity requires an evolution toward GraphRAG. Flowise allows visual configuration of GraphRAG pipelines. The standard database morphs into a knowledge graph for multi-hop queries. To interact with external systems, the Model Context Protocol is used. An MCP bridge creates a standardized communication layer between AI models and external tools. Integrating MCP into chat flows gives these agents multimodal capabilities. Because the platform is open source, the community continuously integrates these new MCP features into the ecosystem. With GraphRAG and MCP, Flowise gives teams a framework to orchestrate next-generation AI topologies directly. We can now step back and look at the multi-layered architecture we've uncovered. This tracks the entire stack, pulling back from the GraphRAG network, up through the Node backend and React frontend, landing on the drag-and-drop canvas. The hypothesis that visual tools are limited to restricted sandboxes does not apply here. The GUI functions as an abstraction layer for a rigorous engineering environment. The result is a stack capable of running Dockerized node backends, PGVector data streams, and GraphRAG retrieval. For technical leads, this allows engineering teams to build complex, multimodal AI agents visually without sacrificing architectural integrity. If this saved you time, hit subscribe. By abstracting the underlying node backend and vector management into a visual canvas, the platform allows engineers to focus on the agent's logic rather than its infrastructure.